All right, finally. I'm Daniel. Let's wrap up the pattern matching section with a little video that will try to make a few pieces of your Scala knowledge click. This will also serve as a slight teaser into the advanced Scala course, but fear not. Let's get to it. All right, so as usual, we'll create a new Scala application. I'm going to call this Patterns Everywhere. Make this an object, extends app, and let's do this. Now, big idea number one. I'll let you draw the conclusions. I'll write a little try-catch exception. So try some code, catch, case. Let's call this a runtime exception and do something. Case NP, which is a null pointer exception, and case underscore something else. Question for you. Doesn't it strike you as odd now that you've learned about pattern matching? I'll leave another second to think about this. Well, I'll spill it out for you. Catches are actually matches. So it's as if I said, try the same code. Too bad comments don't indent themselves. So it's as if I said, try code and catch something in a pseudo Scala syntax and return eMatch and all of these. I'm going to create a little list, which is, let's say, list 1, 2, 3, 4. Okay, and let's say val even, so the even ones, is, and I'm going to use a for expression and say for every x in list, if x mod 2 is equal to 0, then yield, I don't know, 10 times x. I don't really care. What I want you to care is about this generator over here. Doesn't it strike you as odd now that you know about pattern matching? If you're impatient, I'm here to tell you that generators are also based on pattern matching. So all the generators that you have are basically based on pattern matching. If, for example, I have a list of tuples, and let's make this list of 1, 2, and tuple 3, 4, I can actually iterate over those tuples with pattern matching in the following fashion. Let's filter tuples, and I'm going to do a for comprehension, and I'm going to say first comma second, or give the names to the members, left arrow tuples, and then if guard if I want, yield, I don't know, say first times second. So notice how this was decomposed in the same fashion as pattern matching would decompose tuples. And that's because all the generators are based on pattern matching. And for the curious of you, the other patterns are available as well. For case classes, the handy ones with the colon operators, etc. Feel free to try them out. Now, big idea number 3, and this is probably not so much as of a puzzle knowledge click, but this is something fairly new. So if I have a tuple, which is say 1, 2, 3, I can actually say, watch what I'm writing, this is new, val, and parentheses, ABC equals tuple. So I can assign multiple values by exploiting the name binding property of pattern matching. So in this case, A is 1, B is 2, and C is 3. If you're curious, or if you don't trust me, let's just print out one of them, and we'll see the value 2 here to the console. Yes. So we have multiple value definition based, of course, on pattern matching. But this is not limited to just tuples. So all the power is available. So if, for example, I say val head colon tail equals this list right over here, then this is based on pattern matching. This basically says list match and the pattern head colon tail. So if I print head and print tail, head and tail are going to be bound to the members of list. This is extreme power. A lot of magic goes under the hood so that you can simply write this kind of stuff. So if I right click and run this, I'm going to see the values 1 and the tail 2, 3, 4. All right, so this is pretty freaking cool. Now, big idea number 4, and this is also new. We have such a thing as a partial function. So I'm showing this because you might be seeing some weird syntax in practice and you might not know what that is. So remember we had this little list of ours with 1, 2, 3, 4, and let's say I map it in a value called map list, but instead of mapping it with a plain lambda, I'm going to write in between curly braces, I'm going to write some case statements. So case v, if v mod 2 is equal to 0, then return v plus is even. And case 1 is the 1, and case underscore is something else. So you might be seeing this thing in practice with some cases appearing out of nowhere. This syntax is equivalent to saying, and I'm going to copy this over, it's as if I said map list 2 is list map, and for every x, I'm going to say x match against all these cases. So let me put the curly brace here in the proper place. So these two expressions are equivalent. The first expression, this guy right over here, is called a partial function literal. Partial functions are an advanced topic, and we're going to talk about that in the next course. But I just wanted you to know about this so that you don't get scared or freak out if you see this kind of syntax in practice. So the application of this partial function literal, if you're curious enough to print this mapped list, is going to be the 1, 2 is even, something else, and 4 is even. So basically every single element will be put through all these cases. So 1 will match against this guy, so it will return the 1. 2 and 4 will match this pattern, so we'll print 2 is even and 4 is even, and 3 won't match anything. Actually, it will match the wildcard only, so that will print something else. But even though partial function literals are an advanced topic, I wanted to show you that they are based on pattern matching. On pattern matching. All right, people, wrapping up. Oh man, what a journey. You've worked a lot and we've learned a ton. I'm really proud of you. So take a step back and enjoy what you've learned. Until the next lectures and the advanced Scala course, I'm Daniel, signing off, and I hope you had as much fun learning and coding in this course, because I surely did.